So this is the Particles Homework Booklet question 7. We've got a neutral atom of radium and a particular isotope of that is represented by 22888 Ra, and we're asked to name and state how many of each of those constituents of the atom there are. So obviously we've got protons, neutrons and electrons. I'll start with protons because I've got a proton number, so I know there are 88 of those. That is the proton number, there are 88 of them. We're told it's neutral. It's an atom, not an ion, so the number of electrons will match that. And the neutrons, well, I know how many nucleons there are, 228. The nucleons are the protons and the neutrons together. So I need to subtract the number of protons from that nucleon number. There's a nucleon number, subtract the number of protons. That leaves me 140. We're then asked which constituent of the atom has got the largest specific charge. Specific charge is charge divided by mass. We've got two charged objects. We've got the two charged constituents. We've got the protons and we've got the electrons. We're going to be dividing, if we worked out the specific charge for each, we'd be dividing the same charge by a smaller number for the electron. The electron's got a much smaller mass, so I'll be dividing by the smaller number for the electron, giving me the largest specific charge. We're then told that an isotope of radium decays, or this isotope of radium decays by beta minus decay to form an element with the symbol AC. We're asked to write down an equation that represents that decay. So we'll start off with the 22888 radium, and I would go next to the 0 minus 1 beta minus. We represent beta minus as 0 minus 1. It makes no difference to the nucleon number, but because it increases the proton number by 1 because a neutron turns into a proton, we represent it as 0 minus 1 to make it balance. So beta always 0 minus 1 E minus, and therefore what I've got left must be 22889. Don't forget we also do get an anti-electron neutrino, so there was 1 mark for each of those 4 elements. Worth saying here that you might want to think of it, if you couldn't remember what the symbol was for 0 minus 1, what the numbers were for a beta, you could think, well, I know that beta decay increases the proton number by 1 and doesn't change the nucleon number. Therefore, to make this balance, the beta must be 0 minus 1. So I've got 228 nucleons. Afterwards, I've got 228 nucleons. Before, I've got 88 protons. Afterwards, in total, I've got 88, or a proton number of 88. Finally, AZRA is a neutral atom of a different isotope of radium, and we're asked to state a possible value for A and Z. Z is always easy. It's the same element, it's radium again, so it must be the same proton number. It's the proton number that makes it the same element. Remember, the proton number defines the number of electrons, and it's what something does chemically, essentially, that defines what element it is, and chemistry is all about what the electrons are doing. And then we've got to have a different value for the nucleon number. I've chosen 227 instead of 228. They accepted any number between 218 and 238, except, of course, 228. So that's the Particles Booklet question 7.